Okay, let's get started with the changes I want to make for today. Okay, so in the last video, I set up the basics of the physics-based flight system here. So we have all these airfoils in the plane, and these are what generate lift and allow you to steer the plane. It's a lot more complex than the previous flight system that I wrote in part 1 of this tutorial series, which, by the way, is on YouTube right now. You can watch this, and you actually need to watch this if you want to have context on what I'm doing in this video and in this live stream and in the previous live stream. I suppose you don't need to do that if you're already familiar with aerodynamics in general, because we are doing a more physically based one this time. But if you are learning how a plane works from like first principles, then you definitely need to watch the previous videos here. So I'm just going to continue going from where I left off last time. So the current plane I have right now is physically based. It works. You can fly it around. You can steer it. But there's still some problems with how controllable it is. Since the main issue is that I need to tune all of the airfoil so that it actually makes sense and the plane's flight is controllable. Right now it's very unstable on the pitch axis. So I'm only giving a small input to start with, and when I release it, it just whips back around to the center. That's it makes it very difficult to fly like that. It's difficult to aim the guns whenever you cannot hold the plane at a steady angle. It just makes it difficult to control where you're going in general. So the very first idea I have on how to actually fix this is to reduce the strength of these the horizontal stabilizers. So right now I have them set at lift power 20. I can probably reduce that and get something sensible out of it still. Okay, so that does feel a little bit better. It doesn't snap as strongly to the velocity vector as it was before, but it's still not great. And the problem is now that the elevators are really weak. And see, we're going at 470 knots, but we're barely making 6 Gs. This is pretty much where the corner speed, this is beyond the corner speed, so we should be hitting 8 Gs at this point, but since I made the elevators weaker, it's not turning as well. So I can possibly fix that by making it so that the elevators deflect in a larger range. So it should work all the way up to 30 degrees. That means that we'll have a weaker stabilizer and level flight, but stronger elevators whenever we actually give a pitch input. Also, another thing that can help here is increasing the lift from all of these, from the wings, because that'll bring the velocity vector towards the nose direction a lot stronger. So we can make these stronger, and hopefully that will make the plane more controllable in pitch as well. Okay, so that does feel a lot better. We're actually pulling 8 Gs now at 400 knots. The wings are generating more lift, so the velocity vector is not as far away from the nose vector as before. The AOA is smaller because the lift is stronger. And it's still, the pitch stability is still a bit springy, but hopefully you're going to figure out a way to deal with that, not just by tweaking the airfoils. But yeah, just making those small tweaks to how much lift each surface is generating really made a large difference in how controllable this plane is. That was the main thing I was struggling with in the last stream. So we see we can pull 9 Gs in this turn. Plane remains fairly stable. Pretty easy to control right now. Just that the nose vector still ends up being rather springy. So that'll make it difficult when you're dogfighting. But I mean, the AI will also have difficulty aiming there, so I guess it's fair. Okay, so I can actually switch to the dogfighting scene here. So now the player's plane starts in midair, and there's an enemy plane that also starts in midair, and it will just try to kill you. You either need to shoot it down yourself or force it to crash. And those are basically the only things you can do in this project right now. Looks like I got 1 hit on him. The missiles only do 50% damage, so you need to get 2 missiles or you need to get a gun kill. Oh, it looks like he crashed right into the side of the mountain. So the AI was designed for the basic flight sim earlier. Does not really know how to handle the physics-based flight sim. And part of the reason for that is just that the plane is so wobbly. So like on the pitch vector, it's on the pitch axis it's kind of wobbly, and on the yaw axis it's also very wobbly. But the AI is expecting that to be like smooth and well defined. I can actually turn on the AI for my own plane here. Now it's just the AI code fighting against the AI code, so we'll see how it does here. Getting very close to the ground. And he's also close to the ground, but he was not able to save it. So that's 2 battles so far, and both of them have ended with the AI crashing. That's not a very good sign for its quality. Okay, let's go a 3rd time here. Let's see if we can make it do something different and not crash this time. So that's the other problem with this AI is that it basically flies perfectly if you ignore the fact that it can't handle the physics, and it will pretty much always be pulling directly onto your tail, and it never like makes a mistake or hesitates or anything. So that just means that if you, the player, fly perfectly, you'll just be spinning in circles endlessly because the AI is going to be doing the exact same thing. But if the player makes a mistake, then the AI will eventually get an advantage and win. So right now we're just spinning in circles, and neither of us is able to get a shot onto the other, and it won't break like this because we're both able to just maintain the circle indefinitely. Okay, so one of my ideas on how to improve the AI is to add like a delay between when it sees you moving and when it actually like gives an input to respond to that movement. So if we go into the AI code here, which I haven't really explained how this works before. Well, I've explained it how it works on my blog, but I don't have a YouTube video about this right now. But I'll just try to add like a time delay to how the AI acts. So we're going to add a new variable here. Then we're going to add a queue of inputs for the AI to consume. And a new type. Okay, so when the AI determines what direction to steer in, we're just going to put this steering direction onto that queue and then wait for a certain number of seconds before actually moving the plane. So the amount of wait time is going to be controlled by a reaction delay. We're basically going to store the time that the input is generated inside of this queue, and then just wait for the amount of time to pass, and then we can execute it. So the actual input we're looking for is steering. So, oh, hold on, I need to actually instantiate the queue. So in here, whenever we make the new control input, we just set it to the current time. And then we set the input to the generated steering value. So the AI has a couple of different ways to calculate where it should steer. Like it can avoid the ground kind of unreliably, but it can also steer towards in order to get it an angle onto the player, or it can steer in order to dodge a missile. So all of those are just captured in here, which is just the roll pitch yaw that gets applied to the plane component. So we store it here in the queue. We're going to disable the old method, which just responds to steering instantly. We're going to have a new method that will read through the queue in order to find the steering input after a delay. Okay, so we're going to just we're going to like process every event in the queue that's up to a certain time, and just discard the ones that are too old, and just go for the most recent one that is at the appropriate, like after the appropriate delay. So Okay, so we take the time that's stored inside the queue, we add the reaction delay to it, and then we check if this amount of time is already passed. And then we apply the input. So doing this, we can add like a 1 or 2 second like reaction time delay between when the AI generates its movement or whenever the AI, like we add a delay between when the AI generates an input and when it executes the input. Just happened. Unity just, I think Unity crashed. That's not good. Okay, so that's a sign that I wrote this incorrectly. Because I just wrote a while loop here, and that means that we're hitting some kind of infinite loop. Oh, right, I read from the top of the queue, but I never actually remove any elements from it. Okay, so now if we have a valid item on the queue, we remove it from the queue, and if we don't have a valid item, we terminate the loop. And I need to set what the actual reaction delay is on this AI. So let's just start with 1 second reaction delay. All right, it just crashed immediately. That's not, I don't think it's related to the code, but it's just kind of annoying. You can see it flew straight for a second, and then it turned in order to aim at me. So it seems like the reaction delay is actually working right now. And it's still good enough to get on my tail because I wasn't really trying to shake it off right there. This AI still seems to be like flying perfectly. So even with this delay, it's still basically able to be on your tail forever. And I guess it's because 1 second delay doesn't really mean much whenever it takes multiple seconds to do a 360 loop. So even with a 1 second delay, it's like it basically doesn't change the control input it's giving. Oh, but you know what? With this 1 second delay, now whenever the AI detects it's about to hit the ground, it doesn't react until it's too late. So that's why it keeps crashing after making this change. So we need to add a way to skip this time delay whenever we are avoiding the ground. So let's call that let's call it like emergency. That's basically what these routines are doing. So avoid ground would be like an emergency routine. And whenever we're in here, we set emergency to true. Same thing with when we're dodging a missile. Okay, and then whenever the emergency is set to true, we set the reaction delay to 0. So if emergency delay equals 0, so now whenever the plane is going to, whenever it wants to avoid the ground or when it wants to dodge a missile, it'll basically skip through the queue until it hits a event that's actually up to date. Yeah, so it's still crashing to the ground here. Like, it's crashing even more than normal. I'm not sure if that's part of the reaction delay or the emergency system I just added, or if it's just the AI not being able to handle the physics yet. Yeah, it just keeps on crashing immediately. Okay, so I'm gonna see if I can increase the distance it looks at before it So basically the ground avoidance system works by shooting a ray out the front of the plane, and if that touches the ground, the plane will steer away from the ground. So I can just make this ray longer, and that will be more, it will avoid the ground from a longer distance. All right. So yeah, the AI is definitely not able to handle this even with these small adjustments I'm making. I think part of the problem is that the plane is so like unstable whenever you fly it that the AI is just like oscillating back and forth between uh, like pitching up and pitching down, and it just can't pick a stable direction in order to avoid the ground. So going back to the plane code here, I think I can add something here to like dampen the movement to make it a little more stable to fly. Okay, so here's what I'm thinking about. Here's my plan. We're going to take the angular velocity of the plane and use that to sort of dampen the input inside this update lift function. So right now we're just taking the control input directly, and we need a way to dampen this based on the current angular velocity. So I'm going to add a function, or I'm going to add a variable here. So we need to take the angular velocity of the plane, the x-axis is for pitch, we multiply that so this multiplies AV by turn damping, and then we use this to reduce the strength of the effective input. So basically, if the plane is pitching downwards due to stability, this damping should apply us a pitching up motion automatically. So basically, if the signs are in opposite directions, then we want to apply it, but if the signs are in the same direction, we don't want to apply it. Okay, I'm going to switch back to the test scene so we don't have to worry about dogfighting. We can just focus on tuning this damping factor. So this is how much it swings around normally. You can see if the bore sight gets too far from the velocity vector, then gets pulled back towards it. So I can set the damping value now. Not really sure if I can feel the effect. Okay, you can see that the elevators are moving up and down whenever it, like I hold it right here, then I release it, and the elevators still kind of move around. So the damping is working, and it is making it somewhat more manageable. And we can add this for the other axes as well. Okay, this doesn't really improve it by that much, so instead I'm going to go with a different idea. I'm going to take the code I have from the PID controller, which is also on my YouTube channel. I'm going to see if I can implement that and write sort of a fly-by-wire system here. I just need to take the PID controller and add that to my code base. And we're going to add a PID controller here to control the pitch axis. So if you don't know what this PID controller does, you can watch my YouTube video or read the blog post, or there's plenty of other resources on how PIDs work. So I'm not going to get into it here, but basically we wanted to use this to control the like the stick input by measuring the angular velocity of the plane. What are your plans for this? Is it just going to be a tech demo, or are you going to make it into a full game? For this in particular, for this flight sim project, this is just like a tech demo or a tutorial series. I do have plans to make some kind of game in the future. Like it's going to be a flight game, and it's going to be based off basically off of this code, but like with more advanced features, and including stuff that like isn't really relevant to tutorial, like damage and other advanced flight features. But that's basically, I'm not actually making a game right now. That's just something I have planned in the future. So anyways, to get this PID controller working, we need to I don't actually remember what the interface for this is. So we take the, yeah, we can update it here, the current value and the target value. So we want to take the angular velocity of the plane, var av, okay. Okay, so the angular velocity is going to be in radians, so I need to convert that. And what would the target value for AV be? We already have some steering values here. So the old flight system worked solely off of these turn speed values. So I guess we can just reuse these to say what the target value of the PID controller is. Okay, so now this value effective input is just based off of the output of the PID controller. And also, we need to use the effective input here. That was a bug I made earlier. So I have no idea if this is going to work. I've never actually used a PID controller to control the plane's steering before. But let's just roll with it and see how it goes. Oh, you know what? I need to actually put the values into this PID controller first. Okay, so we're measuring it in degrees per second. So the output value is only going to be, the output value is the control axis from -1 to 1, while the input values are going to be degrees per second of rotation. So I don't know. Let's just set these up with some simple values first. So if there's an error of 1 degree, it's going to apply a full stick input, which probably isn't what you want, but let's just see how it flies for right now. Wow, that actually flies surprisingly well. Okay, it's holding the pitch pretty steady right now, but you can see the elevators are actually fluttering quite a lot. Well, not fluttering, but they are twitching quite a bit, which shows that the PID controller is basically just bouncing off of the absolute limits of where it's supposed to, like the limits of output. So you probably since we're dealing with like errors of like 30 degrees, we can probably make this less than 1. So let's say 0.25 for now. The G's you're pulling sometimes fluctuate between 0 and 8. Is that normal? Well, yes, whenever the plane stability goes between, like whenever you release the input, you'll go from like 8 G's to 0 G's really quickly, and then you'll bounce around a lot because the plane is still very unstable. And hopefully with this PID controller, it will result in like a smoother release of the G's. So this is still behaving kind of erratically. Okay, the derivative value was still way too strong. I put them negative for a second because I wondered if it was like a sign error, but no, it's just the derivative value being too strong. And now it's still way too strong because it just like froze my input there for a second. Let's try smaller values. Okay, this seems to be holding it the pitch pretty well. You can see that the elevators are still moving quite rapidly as from the input of the PID controller. I mean, that is kind of how fly-by-wire systems work in real life. They make very rapid changes to your attitude, but I just find that kind of distracting to look at. Okay, so this doesn't change how the plane controls, but just how the animations work. So I can reduce the speed that that everything animates at, and that'll make it look less twitchy. There we go. We're pulling 8 Gs around the corner speed, so it's still turning about the same rate, but now it's holding the nose steady instead of just whipping around. So that by itself should make the AI a lot like a lot more stable in its flight. But before I get back to the AI, I want to add more PIDs for each axis here. Okay, so we're gonna have a separate PID controller for each axis. And then this is going to be simplified to just XYZ. And we need to tune the PID controllers again. Awesome stuff, man. Gotta go, but have fun. Yeah, thank you for watching. These videos will be available on my channel as a live stream archive. And yeah, writing this plane stuff is very fun. And I'm glad that other people find it entertaining to watch me do this. So, okay, we need to set up the roll PID controller. And again, we are dealing with degrees per second in turn rate, but the output is only 0.1, so we probably don't want to set large values for these. And for the yaw, we're just going to set this up as well. Yawing is a lot weaker, so we can probably use a slightly larger value for the yaw PID, but we'll see how this works. All right, that is not controllable at all. Okay, hold on, let's just disable yaw. That looked very strange when the PID controller was just bugging out and everything was wiggling back and forth. Okay, I set the yaw to 0. I'm not sure why that's still... Oh, I didn't change this part of the variable. That's why it wasn't working correctly. So all of them were just feeding off of the pitch PID controller. That's resulted in some very strange behavior. Here we go. Behaving a little bit better now. Rolling seems to work fairly well. Okay, there's some strange behavior. It's not responding to pitch input anymore. It's just constantly pulling up even though I let go of the stick. Oh, I didn't actually save the changes I made to derivative. Actually, let's just make all these weaker for right now. But yeah, the derivative was just causing the PID controller output to bug out there. There we go, that's a lot more well behaved. Okay, so when I put the PID values to 0.1, that made it too weak. Let's just restore this back to 0.25. It still feels kind of weak here, so I'm going to increase this, the P term of the PID controller. Okay, the roll is still too weak. So yeah, I'm just going to be tuning these PID controllers for a while right now. I'm going to modify this so I actually start in the air instead of having to take off every time. There we go. Okay, I think something is wrong with this roll controller because it's not actually stopping me from rolling. So it might be a sign error. Oh, that wasn't it. It was just a magnitude error. There we go. The roll is more well behaved now. It's very jittery, so I still need to reduce the strength of it. Yeah, I need to start setting these I terms up as well because we're still getting a lot of steady state error here. Yeah, I'm not giving any roll input, but it's still rolling to the side. And it's commanding me to roll further. So once again, I'm not sure why this roll controller is not working properly. Okay, that's the other problem is that when you get you're going too fast, target AV no longer makes sense. So I think this is how we can get a G limiter working again, because we had to disable it whenever we moved to this physically based system. So we're taking the old steering code and now we're going to try to apply this to our new steering code. Yeah, so our target AV is now going to be controlled by, it's going to be limited by the G-force scaling. So it looks like the G-force limiter is actually working. Or it might just be that the steering code doesn't actually allow you to go much higher than 8 Gs. Because at 800 knots, if you're getting full stick input, that would result in like a 10 or 12 G turn. I'm still having trouble trying to tune this PID controller here. Okay, it looks like this PID setup I have right now doesn't really work well. You get fast enough, like just sort of, like the input gets so small that we aren't even making enough. Okay, basically the desired turn rate on the pitch axis is so small that the PID controller is not outputting a full 1 value. So we aren't getting the full like elevator authority here, which is I don't know, like a fundamental limitation of how I've written my PID controllers. You could eliminate this if you change the PID parameters whenever your speed changes, but I really don't want to set that up right now. And that's going to require even more complex tuning. So I guess just for now, we have to accept that these planes do not really do well at around supersonic speeds, which is ironic because that's what the F-15 was designed to do. This is basically a problem that propeller planes had, was that you couldn't go above supersonic speeds because of control stiffening, but now we're getting it on this plane. I'm not just putting random numbers into the PID controller. I am tuning them to try to get them to behave well with a large angular speed. Like we're trying to turn it 30 degrees whenever you hit, like whenever you put a full stick input to pitch up, we want 30 degrees input to result in a output from the PID controller of 1. So we need to multiply by some fairly small numbers here. And it does behave well at low speeds. So I guess that's we're going to stick there for right now. So I want to save these values. Yeah, we're not going to be able to get something that works well at low speed as well as high speed. So we're just going to stay at low speed right now because that's I want to tune this so that you can fight the enemy AI and still be mostly in control of your plane. So the pitch PID controller feels pretty good right now. The roll PID controller is pretty well behaved. And yeah, here's a weird consequence of the fact that we cannot turn quickly at high speed, is that our turn rate is so slow that we're still picking up speed even while turning. But anyways, I need to also tune the yaw controller. Actually, the roll controller is not particularly well behaved. So, I mean, this isn't, and I can deal with this, but I need to set up the yaw controller now, because right now we have no yaw control. Okay, that works. A little bit shaky. Yeah, it seems like the yaw is working fine right now. It's mostly just the roll controller that's not well behaved. Okay, yeah, had a way too strong p-value there. So it was like oscillating very slowly to the side. There we go. Now it feels pretty good. So yeah, since you can roll very quickly here, you need to have small values on the PID controller, otherwise it just starts oscillating like crazy. So hold on, I'm gonna save these roll values. Oh, Y485 is in the chat again. Yeah, I'm using, I couldn't figure out how to really get the stability on the, like, how to deal correctly with the stability from the stabilizers, and while also having good, like, pitch authority, so I just went with PID controllers here, which is like a crude way to do it, but I don't want to spend a lot of time trying to tune the airfoil, so instead I'm spending time tuning these PID controllers. Yeah, so I'm not going to put too much effort into tuning the yaw controller, because I'm not using yaw all that much. Okay, but now that we have a somewhat more flyable plane, let's go back to the AI dogfight scene. Okay, so this is a different kind of oscillation. That's because the AI controller doesn't use PID controllers. But it feels quite strange to put a PID controller driving a different PID controller. So I'm just gonna try to dogfight this without the without the AI on my own plane. Oh, it looks like the AI crashed again. So I don't know why this AI keeps crashing here. Um, the ground avoidance routine was working fine before. I guess when I modified the AI earlier, that it's not really helping it. So yeah, anytime it gets close to the ground, it just completely crashes. In another project I worked on, I wrote an SAS type system and was shocked at how well it worked. You mean SAS like a Kerbal Space Program type SAS? I don't really know how that works aside from using a PID controller. It was a sort of PID, but not really. Yeah, I haven't really studied control theory all that much. So I don't know anything except for PID and like just very basic ones. And the AI just crashed immediately again. That's kind of concerning that AI is now. Okay, it might be because of the changes I made to the AI controller here. It may not be actually going through this correctly. So to recap here, trying to add a time delay between when the AI decides to steer to a new location and when the AI actually executes it by basically putting inputs into a queue and then pulling from that queue on a time delay. I'm trying to make the AI stupider in dogfights, but it also made it stupider for avoiding the ground, which is not what I wanted. Okay, I think I put the wrong comparison there. That might be why the AI was not working at all. Here we go. Okay, so it's not just crashing immediately anymore. It's actually avoiding the ground correctly now. So yeah, that comparison bug was causing the AI to basically just ignore all the input commands and just crash into the ground. So I think that means I can reduce this ground avoidance distance since I increased it earlier, but that part's actually working correctly. Oh my god, it's still crashing. So it looks like the AI is still able to get on my tail. I'm just gonna fly in a straight line and see if it's actually able to shoot me down. Okay, this AI is struggling to aim properly, so it wasn't even able to get like a missile lock on me because it was just like swaying side to side and not actually being able to get directly behind me. Yeah, so the AI is still kind of struggling with the physics-based system here. Okay, so the AI is now able to fly correctly, but it's still not able to shoot me down. And it's not because I'm outflying, it's because it's just not able to aim at me. Chris Upex says hi. Hello. One thing I am curious about is how people find these streams, because the last live stream I did had like more interest in the video it was based off of, so more people watched that live stream than watched the original flight sim tutorial. So I'm wondering how people actually find these if they aren't like subscribed to me. I guess if you're looking for live streams about Unity game dev, there's not a whole lot on YouTube. Okay, so I'm going to set the reaction delay on this AI to 0 and see if it's even capable of shooting me down at all. Okay, the AI still seems kind of competent if I set the reaction delay to 0. So let's try setting it to 10 and see how it responds. That means the AI is going to have a 10-second delay between when I like make some new maneuver and when it tries to fly after me. Like, that should make it very easy to outfly it. So yeah, I just flew for like 10 seconds in a straight line there. That's not terribly useful. Way off the map. Yeah, so all of you are subscribed, which I guess makes sense because the only people who watch this live are going to be people who are already subscribed to me. But I don't know, it seems like there was a lot of people who watch the live stream like in the archive instead of just watching it live. Anyways, looks like this my goal to make the AI stupider is actually kind of working because the reaction delay of 10 looks like it actually made the AI do nothing for 10 seconds and then start flying after me. Hold on, I want to do that immediately at the start. So it's not going to respond to me for 10 seconds, which we're going to be in this head-on pass. Then it's going to try to turn to fly after me. Let's reduce that to 2 seconds. Okay, so 10 seconds is clearly way too much. So I'm now directly behind the AI. I want to see how it actually responds. All right, so he's just flying straight down, which is not useful. He's probably overspeeding, which means that he's barely able to turn, and now he's just going further and further off course. Okay, I'm trying to see if there's like a bug in my input queue that's making them not respond to these inputs correctly. So I'm not sure if I'm going to actually find the bug. Very hard to actually write code while also doing a live stream. So this is something I plan to make another part on this tutorial series about after making the videos for the HUD and the AI itself. So I haven't actually explained how the AI works, but that's going to be like the subject of part 3 in this series. And currently I've only released part 1. So if I get all of this working correctly, the physics-based system and these new updates to the AI will probably be the subject of part 4. That almost looked like the AI stalled because it was trying to pitch too violently. Also, one thing I can do since I have this PID controller to control the elevators, I can actually make the elevators stronger again, since I made them weaker earlier when trying to fix this stability issue. It should make the plane a little more responsive when turning, and also it should allow you to bleed off speed more when turning instead of just overspeeding constantly. Okay, let's see if this AI can actually get behind me and shoot me down without crashing or going off course. Yeah, he's struggling to aim directly at me. So, uh, looks like he's not able to like fly in a straight line, which means he flies erratically, even whenever I'm not like maneuvering against him. Yeah, devlog 1 or the tutorial part 1 has no AI in it. It's just the basics of flight. Uh, part 2, which I'm working on, is going to describe how to make a HUD, like the one you can see right now. Then part 3 is going to describe how the AI works. If you check in the description of the video, there is a link to my blog where I already have part 2 and 3 written. So if you want a written version, that also exists right now. Okay, so I still need to do work to tune how the AI like steers, and there'll probably be another PID controller to control the AI steering. Because right now, I can enable AI on my own plane, and we can see that it moves very erratically. So this is what the enemy AI is dealing with right now. This is why it's not able to shoot. And that appears to be why it's crashing as well, because it's barely able to fly in a straight line. Okay, that also has to do with the reaction delay on my own AI, so let's just set this to 0 and see how it can fly with 0 reaction delay. Right, the enemy crashed. Okay, let's try to set the reaction delay to 0 whenever the AI actually has like a firing solution, or whenever it gets close enough so that it's not just like flying erratically behind the target. So I wrote this so long ago, I don't actually remember how this works. Okay, so target position is where it's steering to face, or it's going to turn towards this position. So let's add a threshold. And when you're within some distance, the reaction delay goes to 0. Okay, so now when the AI gets close enough to its target, it will have a reaction delay of 0, so it should be more accurate. SAS code gist for future reference. No, you can't post it. I don't know, it's probably a spam filter. And I don't know if I can actually turn off YouTube spam filter. But I do have some options about modifying the spam filter. No, I can't do that. Okay. Yeah, if you still want to post it, you can like tweet it because I do follow you on Twitter. I'm going to test out this new AI. So let's say when it gets within 1,000 meters, the reaction delay goes down to 0. So it should be able to fire accurately. If I get close enough, he should be able to get behind me and then shoot me down. He's like flying directly away from me right now. Okay, he's able to get at least a missile lock. Ooh, he got me down to 5 hit points. All right, so the AI is yeah, because of the PID controller, the AI can now handle the physics-based code a little better. So still need some time to actually tune how the AI works and maybe adding some more features, but that'll be the subject of a future video. For right now, I think that's a good place to end this live stream. Thanks everyone for coming, and it's nice to see that like people have interest in this flight code and that the PID controller stuff was actually helpful to a lot of people. So yeah, I don't have a very regular schedule for streaming, but I do mostly want to do it on the weekends. Today is like Tuesday, so um, try to get it more on Saturday and Sunday in the future. Are you going to add vape trails in the future? Like vape trails off the wings? That's like a graphical effect, which I don't really want to put into this flight sim series. The missile only has a smoke trail to make it visible from long distance. But for vape trails on the wings, I don't really want to add that. Also, I don't know how to add that. Anyways, this physics-based code and the AI will be the subject of a future video. Thanks everyone for coming, and I'm going to end the stream now.